Welcome to the webinar Architecture and Deployment of Gray Cortex Mendel. I put a small agenda together for today, and I like to talk about the deployment. You know, there are a lot of people who do have problems to get the right information on the system, or to make the right decision, what to install. Do I need an all-in-one device? Do I need a collector? Do I need sensors? What is possible? Can I go for hardware? Can I go for virtual? Is it possible to have a mixed solution? Is it possible to put something on hypervisor or something in the cloud? Okay, so let's talk about it. The second part is about the traffic mirror sources. How can we get a copy of data? How can we do that based on all kinds of methods are available. You can use span ports, of course, all kinds of span sessions. You can set up tapping devices, aggregation tabs, packet brokers, that kind of information. We can get a copy of the raw traffic, of course. There's another way to get some additional information from the traffic, like flow information, NetFlow information, IPFIX information, and NCell information, JFlow, NetStream, that kind of things. SFlow is also possible, of course. While we are not recommending SFlow because it's sampled, and for an NDR system, which is detecting vulnerabilities in the network, then it's not good to use sample traffic, because then you will see that the bad sessions maybe are not in the sample and will pass the system without creating an alert. So for security reasons, we don't like to have sample traffic. I will explain a little bit later about these sources for data. What we also can do is we can send log information from network elements to the system to create some alerts if you want. The next item is licensing, because there is always impact between license and the architecture, of course. The more sensors you need, the more collectors you need, the more license you need. So we will talk about it and show you a little bit the difference in price between collectors, sensors, and the type of sensors we will have. I will show you the hardware portfolio. That means I show you the rack mounted servers from Dell we have, but we have also for OT solutions, thin rail mounted and ruggedized small servers available. And then when everything is clear and we have everything installed and it's running, then still the system needs to be configured in a way, right? So I will go over some configuration steps only for the deployment. So not for analyzing traffic, that kind of things, but just to show, do we have set up and configured the system okay, so that we can work with it in daily basis. Saying that, let's go to the deployment setup. Basically, how we can work is like you see on top. We can work with a sensor and a collector. So basically, the system has a collector where all the data is stored, and we have a sensor where we can offer a copy of the raw traffic, and it will process it and send it to the collector. You can have that solution in one appliance, and we call that an all-in-one. An all-in-one appliance is basically a collector and an embedded sensor. That's what it is. What we also can do is we can use single sensors on other locations and send that data to the collector. It doesn't matter if it's just a collector or it's an all-in-one device. So to an all-in-one device, you can also hook up sensors. Later in the practical part, I will show you how it looks like, because in my lab environment, I have an all-in-one device running with an additional sensor. So the idea is for the sensor, send a copy of raw traffic, and you can do that with a span port, with an RSpan, so spanning over layer 2, or an ER span, and that's spanning over layer 3, of course. If it's possible, ER span, remote span will take additional bandwidth in your backbone. So you have to take in mind when you are transferring a copy of traffic over your existing backbone, it will need additional bandwidth. So take that in mind. There is also a possibility to have there a tapping device in the links, which will make a copy of the traffic, or packet brokers, which can take a part of the packets and send it to the sensor. And there's also a possibility to use aggregation tabs. So that means when you have multiple tabs, that you can aggregate it and send it to one sensor. So that means with an aggregation tab, you can lower the number of sensors needed. What will happen is that the raw traffic will be sent to the sensor and it will be processed there, and the advanced security network metrics will be sent to the collector. And roughly that's looking at the bandwidth, it's about 2% of the traffic which is offered to the span port, and that's what we call throughput traffic. Sensors are available in with several monitor interfaces. So it will start with 100 megabits per second, but it can go up to 2 times 100 gigabits per second. What you see is here the collector with separate sensors. So that means one collector can, and it depends on the type of sensors which are connected to the collector, of course, but at least 50 plus sensors you can hook up to a collector. And the aggregated traffic could be maximum 100 gigs per second, bits per second on the collector itself. The collector is used for central event management and visualization, and all the data basically is stored on the collector. So all the configuration is made on the collector itself. If you look what type of appliance you need, so here it looks like it's a physical appliance, a hardware appliance, but basically the software is available as the solution is available as software. So that means that you can install it on a virtual machine like VMware, Hyper-V, or KVM based systems. Also, we support cloud solutions like AWS, Azure, and Google Cloud Platform. In case you like to install it on the hardware, you can install it on your own hardware. You only need to fulfill the requirements we have for the software, of course, and use the right interface cards where we have the drivers for configured. If you order hardware from us, then you will get a Dell appliance, but I will come back to that later. Talking about span ports, you see it here. One thing is for sure, we need to have both directions in a span session. So that means TX and RX, we need to see it in a span session. You can imagine that if you are monitoring links, that the utilization will exceed 100%. Just an example, all the RX traffic you see is 50% of the 1 gig bandwidth link, and the TX traffic is 80% of the 1 gig link. That means together, because in the span port you will have TX and RX together, that means that it's 130%. So that means that not everything fits in a span session, and that means that you will get packet drops, so you don't see all the traffic. In that case, you could split the traffic and send it to two monitor ports on the sensor itself. So that means you can, for example, say the TX traffic is sent to interface number 3, and the RX traffic is sent to interface number 4. The only thing you need to do, and I will show you that later, is that you will merge these interfaces in the configuration so that Regatta knows that it's one session of data. The same, of course, for NetFlow information. You can send NetFlow information to the collector. You can send it to a system port, or you can send it to the management port. And that means also when you configure NetFlow information that you have to have both directions in the flows. Otherwise, the system can give you false positives and also do the wrong tagging for it. Except NetFlow information, we can send log data. So that means that you can send log files from external systems to the Gray Cortex, which can create alerts for something. I have an example in the demo, which I can show you. Let's see, what can we do with an additional sensor? Why should we use an extra sensor? Yeah, like you saw, the sensor can be used, for example, if there is a lot of data, if it's high performance, if it's 100 gig interfaces, then you know that all the resources needed to process the data is for the hardware appliance. So if you have 3, 4, 5 100 gig interfaces to monitor, you need to have multiple sensors. What if you have not all the data on one location? So it's geographical over the country. That means that you have several locations to monitor, and you can't send span ports, span information over the internet, or you don't like to do it. It's eating too much bandwidth and it's unsafe, or you need to put it somewhere in a tunnel, but it's not the best solution. The best solution is to use an additional sensor for that. What if you like to monitor in a hypervisor a virtual switch and monitor the data which stays on that switch? So you have some virtual hosts running in a hypervisor, communicating with each other, and you like to monitor the data. So the data is not getting out of the hypervisor, so you can't monitor it on the outside of the hypervisor. Then it would be nice if you can install a sensor, an additional sensor in the hypervisor monitoring traffic on the virtual switch. So that's possible. That also gives you the answer that you can combine virtual sensors with physical collectors, physical sensors with virtual collectors with virtual sensors. So it's complete hybrid, so you can mix what you want. What if you don't have remote span enabled on your switches or routers, or ER span is not possible? Then you need an additional sensor for that. Same if the backbone is not robust enough to carry the traffic for ER span or remote span, then it's better to use a sensor, because then the traffic is only max 2% of the offered data. Sometimes you like to have an additional sensor because you have your traffic segmented. So that means that you have segments for example, for OT and for IT, and it's completed separated from each other. So it's not possible to see the traffic from the OT in the IT side or the other way around. So that means that you need to have a separate sensor in these segmented sessions. Another advantage is if you are, for example, an MSP. So you have multiple customers you like to monitor, and you like to see that traffic separated. In that case, we call it multi-tenancy. You can monitor multiple end users for you, multiple customers for you, with a separate sensor. So that means later, when all the data is collected on the collector, you can really filter out based on sensor all that traffic. Why based on sensor? You should say, yeah, but when it's I can filter out on subnet. Yeah, but most of the time customers do have the same private subnets, so there will be an overlap. So that's not an ID to filter. So when a sensor can bring you the solution for that. What are the advantages of to have to an additional sensor? Or what are the pros and the cons for additional sensors? Let's say it that way. So the more appliances you need, the more licenses you need. So that means the more costs. And you like to have a cost-effective solution for your monitoring. So just to give you an idea, when we look at the sensor and we compare it by an all-in-one device, that means that the price of the sensor is maximum 20% of the all-in-one device. If you look at sensors, we have sensors in all kinds of formats, of course. We have SX sensors, that means extra small. We have small, we have large, extra large, and that kind of things. If you look at extra small sensor and you compare the price with a normal sensor, it's only 50% cheaper. So to have multiple sensors, it doesn't raise the cost so much for what it will bring. So one of the cons, additional costs, but it's not so much. So, and another issue is there, or not an issue, but a con is that deduplication is only possible per sensor. So if you have multiple sensors in the same network, not when it's multi-tenancy, it doesn't matter. When you have a sensor for multi-tenancy on one customer and on the other, then for each customer, the deduplication will be done. But if you have one network for just one solution and you have multiple sensors, deduplication is only possible on one sensor. So not over multiple sensors. On the other way, there are also a lot of pros. So you can use it for multi-tenancy. It's easy to expand. So it's when you have an hypervisor, it's easy to put a virtual sensor inside. And there is load risk distribution. So if you have too much traffic, you can share it over multiple sensors. So that's also good to know. What if not everything is fitting on one collector? Because you have multiple sensors and you have the biggest collector there is in storage and speed, but you need more because you have a very, very large environment. It's not that it happens so much, but I like to show you how we solve that kind of solution. In that case, we have a central event management system, which can be connected to collectors with sensors or you can hook up a sensor to a SAM system, or all-in-ones, and all-in-ones also with sensors. And there is a central event management system. It doesn't contain all the data, because the data will be on the collectors itself, only for the single sensors, which will send the data to the SAM system. The data is stored there. But from here, you can see all the events over all the appliances in the network. So, and all the data which is monitored by the system. So I'm not going to explain further what it means, but it's just that you know that it's possible. When we look at our hardware portfolio, just to explain what you see, it's an all-in-one device. So that means for hardware, there is an S and a C, and the S stands for sensor and the C stands for collector. And when you look at the collector, you can see the hardware is only the C for collector. And if you look at the sensor, the hardware is only for the S for sensor. And then it means, the second part means that we have a size, and the size has to do also with performance. So that means the number of memory, the number of cores and threads, and that kind of things. And the number of disks, that's configurable, because it depends on how long you like to store data. If it's only for a couple of weeks, or it's for multiple years, you know, so that has to do with it. So the XS stands for extra small, and we are going like with a t-shirt, from extra small to large, to medium to large, to extra large, to 2 times extra large, 3 times extra large. So the biggest one is 3 times extra large, right? That's the all-in-one device. When you all-in-one device, that means it's collector part and it's a sensor part, and the sensor part can collect data from 100 megabits per second to 25 gigs per second. So it's not possible to have an all-in-one device monitoring 100 gig or 40G traffic. So that's not possible. If you have 100G traffic, then you need to have a collector and a sensor, so separated. For the collector itself, it's the same. We are going not from extra small, but from small to 3 times extra large. And that means that we can handle the traffic for 1 gig to 100 gigabits of aggregated traffic. So here, the collector will collect aggregated traffic from the sensors, right? And the sensors are also from extra small to extra large, and that means they are going from 100 megabit with multiple interfaces. I will come to that in the next sheet, to 100 gig per second, right? I told you, if you are ordering the sensors or the collectors from us with hardware, you will get a Dell appliance, and the smallest Dell appliance you will get is an R360 with it's 1U with 8 times 2.5 inch slots for disks, 32 gig of RAM, and Xeon processor with a dual power supply for 600 watts. And the biggest one is the Dell R7625, which has 2U height, and it's able to carry 16 times 2.5 inch slot for disks, and 24 times 64 gig on RAM memory, and there is a dual processor with 32 cores and 64 threads, and a dual power supply for 1400 watts, just to give you an impression what is inside. There is also a possibility, of course, when you install everything on that big appliance, that you have fast disks for the short time memory and the operating system, or the short time storage and the operating system, and yet you can use another type of disks, for example, spinning disks, for the long time storage. So it's up to you, because if you like to save costs, that's a way how you can do it. For other solutions like OT, it's not good to have a kind of a Dell server there, because most of the time it's not a clean environment. The temperature is high. Maybe the humidity is different. Maybe there is dust. So you like to have there more ruggedized servers available, which you can use maybe on a DIN rail mount. That's what we have. The smallest one we have there is the Advantic Uno 127, and the largest one we use there is the Dell Edge 5200. So basically these can run as a sensor or an all-in-one device on OT and environments. Okay, that brings me to if you have the server, you need to have interface cards, of course, to monitor the traffic. And we have some standard monitor interfaces which can monitor traffic to 1 gig metal. So that means RG45 connection, 1G and 10G. Or there is a possibility to have an SFP slot available, SFP28. Interfaces can monitor traffic from 1 gig to 2.5 gig. So on the SFP slots, of course, no additional licenses. Licenses are based, like you know, probably on throughput, a number of IPs, and in case of a collector with NetFlow information, also the number of flows per second, of course, you offer to the system. What you see here is that we have several cards available. The Broadcom card with a quad port, metallic 1 gig. In a unit, you can put 2 cards, for example. That means you will have 8 slots, and there are no additional license for that if you have 8 connections or just 4. So it's the same. So we are not licensing based on number of monitor ports. You can make a mix of these cards, so that's not a problem for that. 10G base T interfaces we have. Take in mind, if you are using 10 base T, that you have the right cables and not too long distance, because the distance is limited, of course. If you look at the SFP slots, you have to have, of course, compatible SFPs, which we use with the cards. So you can see that in the specs from the cards, that you have the right SFPs, which we can support. There are SFPs I know you can rebrand. That will work too. We had that in the past. Working with SFPs is also challenging, of course. Depends on how you use it. If there is a short distance, maybe you don't use an SFP and a cable, but you use just a DAC cable, direct access cable. That's a simple solution. You don't have to look for the right SFP wavelengths and the right patch cables to use. Is it's an OM1, OM2, OM5 in single mode or multi-mode. So there is no confusion if you use a DAC cable. Take in mind, if you use, for example, a span port where you send the data to a monitor port, that you have the same SFPs on both sides, at least that they can operate together. While we are using only the RX on the monitor side of the probe, it means not that you only have to put one single fiber there, because most of the time SFPs on a switch are looking if there is light received. Doesn't have to be data. If there is light received, if there is no light received, say stop transmitting, and that's just that for protection, that the laser doesn't send out light, so that can hurt your eyes. So it's a protection mechanism. So we are only using on the monitor ports, on the span ports, the RX of course, but the TX needs to be connected too. There are different ways to monitor optical traffic. You can also use optical splitters, and for that reason you really need to know exactly the type of SFPs which are used in the link from source to destination. If you put there an optical splitter in between, you need to have the same kind of SFP in your monitor card to work with the traffic, and use the right patch cables. Also, something you need to keep in mind is the type of optical splitter you will use, because the level sending from the laser from the source to the destination, that means there is some attenuation, there is that some light will go get lost, and due to the splitter you use, there are all kinds of splitters. You have 50-50, so that means that 50% will go from source to destination and 50% of the light will go to your monitoring system. And if then the budget to the destination is too low, then you made the wrong choice, because there are also splitters for 30-70. So that means that 70% of the light will go to the destination and 30% will go to your monitoring system. So really, it needs a kind of a design. It's not just put a splitter there and go. So that's not how it works. What if we have we need more performance on the network monitor cards? That means that we have FPGA cards. That means field programmable gateway array cards. From Napatech we use. It's the only brand we support at the moment. That means high throughput and low packet drop. And also there is processing done on the card, so it has less requirements from the sensor itself. And yeah, so it looks very positive. It is really. So if you need to have 2 times 100G to monitor, then we need to have this card. You see in the overview what the card can do. So it's 2 times 100G or 2 times 40G or 4 times 25G or 10G or 8 times 10G. So it's flexible. The cards which are here we do support. Keep in mind that the price is pretty high, but on the other way, if you can merge all kind of data to one single sensor, you can save costs on another side. FPGA cards. One remark is there, if you like to have in your sensor one FPGA card and one regular card, that's not possible, because Surigata can't work with a mixed setup. So it's not possible to mix, for example, 4 times SFP 28 slot for 10G in combination with the 2 times 100. So that's not possible. So it needs to be all FPGA cards or regular cards. Of course, you can make a mix for management or system interfaces. That's not a problem, but for monitoring interfaces where the raw data is sent to, it needs to be the same type of cards. Okay, then it's time to get practical, right? Let's go here and let's start with the performance things. So let's go to the status monitoring. In the status monitoring, we have an overview where we can see the number of CPUs which are configured and the CPU cores which are used. So in in a hardware environment where you can fulfill the requirements which we ask for it, and if you buy the hardware from us, then we make sure that there is enough CPU performance. It's the same for the disks, of course, and for the memory. But in a virtual environment, maybe there is a lack of resources, and here you can exactly see what can happen. For example, if you look at another date, and let's see, then we can see that something happens here. Let's zoom in. So you can see that the number of cores are 20 and something happens here. And then you can see that the load is 3.82. So it's not exceeding the maximum line. So there is no reason to upgrade the CPU cores in this case. It's the same for the memory overview. You can see the number of memory which is used. I have to tell you, the setup you see here is for the whole system. So if you like to see it for an individual system, then so first I show you how my setup is created. So it gives a better idea that I told you that I have a mobile all-in-one device and a sensor. So I can look at the performance parameters for the mobile all-in-one and for the sensor separately. So let's go back here. And let's look at the sensor itself. And then I can see that basically there was an outage here. You see, when I zoom in, then you can see the dotted line. Here it's a straight line, so there is an outage. And the outage will be seen everywhere. So that means that all-in-one device, the collector, which is displaying it, didn't receive the signal at the time. And here you can see there was an alert like service disruption. If we go back to the all-in-one device, we see what's going on exactly. So here was the reason for it. Something was going on. It has not to do with the number of cores. There were a lot cores enough configured. It's also for the memory, and the memory we can have it also in details. I will show you in a minute. And here is the traffic overview. So you can see here the management data. That is the data monitored on the management interface, and it's also showing you the data from the sensor, of course, because that's sent to the management interface. When we are going more in detail here, you can see the memory and how much memory is used for the processes. So that means if, for example, the IDS is needing more traffic and on more memory, and it's exceeding the total amount of memory which is assigned, then you need to assign more memory, or you can change the performance parameters for the process. Where to do that? You can do that under settings. When we go to settings, and we can go to the sensor and collectors, what you see here, and we have here under the collector, in this case the all-in-one device, under others, you can go to configure, advanced, and here you can see the database performance profile. So if you need to raise the number of RAM, in my case it's a very small sensor which is there, but here you can change the number of RAM memory used for the database processor. Keep in mind that at least the RAM should be available on the sensor itself or in the collector. It's the same for the detection engine. It's 16 gig by default for the smallest one, and it can go up to 1 terabyte. And it's the same for NetFlow performance profile. If you don't have NetFlow there, then you can keep it what it is, but this is how you can tune performance parameters there. Another thing which you need to keep in mind is, for example, on the monitor interfaces. When we look at the monitor interfaces, and you can look at the monitor interface on the all-in-one device. So here you can see the monitor interface. It's used for ER span, or you can go to the collector itself or to the sensor. So you can see you can manage it from the collector. Here is the monitor interface. It's a span interface. If you are using 10G interfaces, that means that you need to adjust the ring size. There is some recommendation here for 10G monitor interfaces. You need to have a bigger ring size, and that's the same for the number of threads which are used. So basically it's 6 for a normal monitor interface. If you are going to 10G per second, then you need to change this to 16. Something else, and it depends on the type of frames you will have on your network. If you have jumbo frames, for example, because you have an operator network or another network with jumbo frames at least there, then you need to change this to 9K, of course, MTU size. So like you see, everything is adjustable, and yeah, keep in mind that it's configured the right way, because yeah, it needs to have some manual adjustments. Something else where we have to look at is, I told you when we are monitoring the data, you need to have bidirectional traffic, right? We need to see the TX side and the RX side to have the right labeling connected to the system, and yeah, less false positives. How can we check that? Yeah, sometimes you can check just by saying, okay, let's see what we see for a protocol which we know which is in the network, like Samba, for example, and we are looking for the Samba protocol on my sensor in this case. And we look at the services which are there. So you can see there is a Samba protocol on 2 ports. On 445, it's for data exchange, and on 138, that's just NetBIOS. So if we look at this one, you can see that the data bytes in are there and the data bytes out are not there. So it's one-way traffic, and here you can see for this one, because it's local and remote. And when you're familiar with the Grey Cortex, you know local means that the service is running on the server itself, and remote means that it's running on a server remote. So basically this is seen from the client side and this is seen from the server side, but it's, yeah, reversed. That's okay. It could be also multicast traffic, of course, or broadcast traffic, I mean. Here on 445, that means data exchange is there, and you see the data in 2 directions. Just to prove it, let's go to one of the information sites. Here you can see that the Samba is just in the request and in the response. One thing I told you is that if you offer the traffic both ways, but it doesn't fit in one link, you need to split it over 2 links. And if you do that, you need to tell the system that it needs to merge multiple monitor interfaces, and you need to configure that. So let's show you where to do it. So if you go to settings again, and we are going to sensors and collectors, and we are looking at the interfaces itself. We did configure them, and in the components you will see there's a network capture, and you can configure that, and here it's merging traffic for multiple interfaces. So you need to turn that on if you have your traffic divided over multiple interfaces on the sensor. So you need to tell the system that it needs to be merged, because otherwise it will handle it as a single interface. So that's what you can configure here too. Just to explain that it's possible. I already told you ring size, buffer size, and that kind of things you need to monitor. That brings me to the next item. And that means that we have in the system an automatic inventory detection system. So that means that we are looking at the data, and during the setup, it will ask you the number of subnets you will have, but it also will detect it automatically. The only thing we need for that is to see the DHCP traffic, right? That's what we need, because in the DHCP traffic, we see the subnet which is assigned to an IP, and in that case, we can create the subnet our own. In this case, you can see that in my sensor 3, there is an automatically created subnet, and that is this subnet. Why do I need the subnet segmentation? So that we need not the biggest private subnet, but all the smaller subnets. That I like to do that because I can add a policy to it, you know, and the policy can warn me just in case something is wrong in that subnet. First, show you how it's detected. So in this case, it's automatically detected here. So when I go to the network and I clear this one, I will go to my sensor 3, filter it, and I will go to this subnet because it's automatically created, and I will filter it. And I will go to the service, the HTTP. I will go to the details. Then you can see in the DHCP there is a request and a response. So the response is that this IP address is assigned by my DHCP server, and this is the subnet which is there. So that means when DHCP is seen in the network, we can automatically detect subnets. Good to know. What we also see in this inventory is when we don't have the HTTP there, that we can create our own subnets, right? And here, for example, in the 70, I created a policy, and that means here in this case I have a window for 8 days, and when there is a new host detected, it says denied. It's not that we are blocking it, but it will give you an alert. And it's the same when limits are exceeded. So I can here put alerts when in a certain subnet limits are exceeded. How does it look like? When we go to events and we clear this one, the filter, and we go to events and we go to limits, then we can see here that limit duration at the host is exceeded. So you saw that it was in the subnet 70 at the end, and this one exceeded the 5 minutes, the 300 seconds. So when I go to more details, then you will see that the model is 86 seconds, but it's measured 300.41 seconds. So it's exceeding the threshold for 300. So that's something you can do with policies assigned to subnets. So for that reason, it's important if you have multiple subnets that they will be recognized automatically. If the HTTP is not seen, at least create them. They're your own. Something else what we can do with the system is for the proxy, for example. If we have a proxy in the network, we could go to the network and look for a host tag. And the host tag could be proxy server, right? And look for it. We see proxy servers. Let's go to the sensor 3 in this case. We see proxy servers on 2 addresses. When we look here, you can see that the automatic tagging engine did add here the role proxy server automatically, because it was detected that that unit was used as a proxy server. When we look here at the proxy server itself, we see that all kinds of ports are used, but like you know, the proxy port is or 8080 or 3128. So let's go to 3128. So when we look at 3128, you can see that this device, and this device is my PC in this case, it's using the proxy server to get outside. So when we look here, you can see that there is a connection from the 25 to the proxy server. And you can see that I like to visit a website, hogeschuts.nl, and I got the status 403, which means forbidden. So that means that the proxy server just blocks this request. This is the communication between my PC and the proxy server. What we can do is, of course, add this one to the filter. Remove the role proxy server, of course, and filter again. And then we can see that some communication is to the proxy server, but there is also communication to the public IP. When we go to a public IP, for example, this one, we see the connection, which is set up here with the 200 OK. And we look at the network layer, we can see that there is a proxy configured, and the proxy address is the 252. So that's what we saw in the previous one. You can configure this under settings. Under proxy visibility, you can see I have a Squid proxy server in my network. It's running on the sensor mobile all-in-one or on the other one, doesn't matter, because this is the all-in-one which can detect it. So that means that the IP address is 252 and the port number is 3128. If you configure that, that means that you will see the network connections for the proxy server here with the correlation inside, right? I told you that we can create also alerts based on log files, for example. How can we do that? When we look at the events at the moment, and we clear the filter here, then we see that we have an event here, Squid TCP denied, and in my case it's a layer 5 event. But here you can see it exactly tells you that the 252, so that was my laptop, was trying to get to Hogeschuts and access was denied. Okay, you saw it in the flows, but if you like to have an alert for it, you can create an alert for it just by sending log files to the system, and it will query it and it will show you that. I showed you that we can search for limits, and I showed you that in a certain subnet limits are exceeded, but you can also search for performance parameters, for example. What you can see here is that some application performance status is exceeded. So there is an outlier for that. So when we go here, you can say, okay, so the 252 has some problems. So let's see what is really going on. And we can go to in details here. So we see here the user experience time. So there's nothing measured. There's only a model, so nothing wrong there. But with the application response time, you can see there is a model for 0.7, but measured is 29.66. So it's 41 times more than normal, right? So, and that is what the system will show you. We create models. Maybe I don't have to explain it here to you, but for subnets and for hosts. So that means that we have detailed information for the total subnet and for the hosts based on the items which were there measured, right? So in this case, it's not only for this application specific. And if you go to the flows, then you will see that it has to do with this one, and that information is available there. Saying that, there is one thing more which is very important, and that is I should have started with it because it's the most important thing before you set up your monitoring system. It's the configuration of the time, the NTP, of course. So you need to go to the global settings and put your NTP server there, because everything needs to be correlated with the right time from the events in the network. If it's not correlated, then it doesn't make sense. Then you are looking at the wrong time for events. So that's not okay. So NTP is very important. It's not only important for the monitoring, but if you like to set up, for example, a new system on a hypervisor, then when the hypervisor is on the wrong NTP timestamp, it doesn't mean times on, it doesn't really mean timestamp. So if you, last week, I had an installation with a hypervisor which was on January 25 some date, and then you can't install the new software, because during the installation the license key will be checked and the date will be validated, and it will not work if the time in the BIOS is not correct. So you need to take in mind that everything is configured there. Looking at the time, I think we are almost there. I touched everything I want to talk about. If there are questions, please reach out to us and ask the questions. And yeah, for now,
Yeah,
I
Tony,
like.
there are two questions actually. So
Okay.
should I read it too?
Yeah, I don't know if I can
Yeah.
see them.
Are there any limitations on the license when hardware changes occur? For example, how many licenses can be reactivated if hardware replacement is performed?
Yeah, basically what we have is we have a kind of what is it, a policy when you exchange hardware because you need to upgrade, then we can exchange license. So basically that's what we can do. So the license are based on throughput and based on number of endpoints. If that all is the same but your hardware is not strong enough anymore, then we can say, okay, we will get back that license, remove it from the old appliance. The new appliance will be installed and you can use the license again. And when you buy the license, we will give you the license for a certain number of appliances. So when you run out of, if you install a new appliance, added to the existing appliances, then of course it will eat a new license. When it's your server burns down and it's not repairable anymore, for example, and you need to buy a new one, then we can transfer the license. So that's how it works. So,
then there is a second question. Is there an estimated hardware usage, including the IOPS requirements for sensors and collectors based on the processed throughput volume?
yes, there is a requirement for the IOPS, for the disks, because if we process the data, and that's in our hardware recommendation. So we will tell you, these are the number of IOPS you need. So most of the time in the fastest collectors we have, we don't use spinning disks, we don't use SSDs, we use NVMe disks or NVMe for that. That's the most fast storage at the moment. And I already told you, if you have your operational data, for example, which you need to have fast, accessible, you can run that on a separate part, on a separate disk set, RAID set in your appliance. And for the long time storage, you can choose for cheaper disks, because you need to have there maybe, I don't know, 150 terabytes on spinning disks. It's cheaper than have it on SSDs, of course, so you can split it. But for sure, there is a recommendation for IOPS. So and that will be part of the recommendation. So most of the time we run a kind of a POC that we know the number of IPs, the number of throughput, and if there is additional NetFlow information. And with that information and the information from the customer, which he tells us how long storage time he needs, we give him a recommendation. This is what you need. And if it's if they need the hardware from us, we will recommend this is the Dell appliance you need, or we order it for the customer, and he get it from us.
Thank you. Then we have a last question in the chat. Is there any possibility to integration to any EDR market?
Yes, we have integration, for example, with ESET, that's operational, but basically our complete system has an API to get information out of the system or get information in the system. So yeah, we can always help end customers to integrate other EDR systems than from ESET we have at the moment, but that's what we can do. So we are pretty flexible in that. Customers can do it themselves. There is a Swagger interface for the API, so they can play around with it. And if they need some help, they can just send a request.
Thank you, Tony. If there are any other questions, we will send a follow-up email with the recording tomorrow, so you can also reach us via email. Thanks.
Thank you for this time. See you next time.